represented by the equation y equals to a sine in bracket 2000 pi t minus pi x over 17, where the symbols have their usual meaning. Calculate I, the wavelength of the wave, II, its speed, III, its frequency, IV, its period, and V, phase difference if the two layers of the wave are 180 cm apart. Solution: y equals to a sine in bracket 2000 pi t minus pi x over 17, where t is in seconds and y is in cm. We also have that y equals to a sine 2 pi over lambda in bracket vt minus x. Therefore, 2 pi v over lambda is equals to 2000 pi, and 2 pi over lambda equals to pi over 17. Wavelength is equal to 2 pi times 17 all over pi, which is equals to 2 times 17, which will give us 34 cm. II, 2 pi v over lambda equals to 2000 pi. Therefore, speed v is equals to 2000 pi times lambda all over 2 pi, which will give us 1000 times pi, which is equals to 1000 times 34, which will give us 34,000 cm. I, frequency f is equals to v over lambda, which is equals to 34,000 over 34, which is still give us 1000 Hertz. IV, period t is equals to 1 over f, which is equals to 1 over 1000, which is equals to 10 raised to the power minus 3 seconds. V, since the two layers are 180 cm apart, they are separated by 180 over 34 wavelengths, or by 5 whole number 10 over 34 lambda. The phase difference for a separation is equals to 2 pi. Hence, for separation omitting, 5 lambda is equals to 10 lambda over 34. Phase difference is equals to 10 over 34 times 2 pi, which is equals to 10 pi over 17, which is equal to 0.588 pi radians. Wave is a disturbance that carries energy with it through a medium and transfer energy from one point to another without causing any permanent displacement of the medium itself. This transverse wave, this is the diagram or the graph of a transverse wave. For longitudinal wave, this is the motion. Velocity of the wave v equals to lambda over t. Wave y equals to a sine 2 pi ft. A equals to position of its state of rest. Y is equals to, in bracket, capital A sine 2 pi t all over capital T. Y is equal to capital A sine 2 pi x all over lambda. Equation of wave that starts from the origin, y is equals to a sine 2 pi f in bracket t minus x over lambda, where y is equals to the wave function, a is equals to the amplitude. Example 12. A certain wave is described by the equation y equals to 4.2 sine 1000 in bracket t minus 7.8. If the horizontal displacement of the wave particle is 7.37, calculate I, the amplitude, 2, the frequency, 3, the velocity of the wave. Solution. Number 1. our amplitude A is capital A is equals to 4.2 meters. Question 2. Sine 2 pi f is equivalent to sine 1000. Sine 2 pi f is equals to 1000. Therefore, f, making f the subject of the formula, we have 1000 over 2 pi, which is equals to 159.16 hours. Solution 3. V is equals to f lambda. S over lambda is equals to 7.8. Therefore, x is equals to 7.8 over 7.8. X is equals to 7. What we are saying here is that V is equals to f lambda. We know that our frequency is 159 and our wavelength is 7.37. That is all. That is the wave particle, which is equals to 1171.8 meters per second. Characteristics of wave. They can be reflected when it rebounds a certain medium which are in angle. Refracted, it can pass through a medium. Diffraction, which happens when a wave travels through an opening. Interference, where the two waves are superimposed in the same phase. Example, crest on crest, we get lines of increased disturbance or constructive interference. Light wave, pinhole camera and image in plane mirror calculation involves pinhole camera. Height of image over height of object equals to distance of image from the pinhole over distance of object from the pinhole equals to length of camera over distance of the object from the pinhole. Example 1. The screen of pinhole camera is square, of size 160 mm and it is 150 behind the pinhole. The camera is placed 11 from the flag staff and the position in such a way that the image of the flag is formed centrally on the screen. Is the image occupies 3/4 of the height of the flag staff? Solution. Height of image over height of object equals to image distance over object distance, which is equals to height of image over height of object, which is equals to 0.15 over 11. Making height of object the subject of the formula, we have 11 over 0.5 times height of image, which is equals to 0.16 times 3 over 4 times 11 over 0.15, which is equal to 44 over 5, which will give us 8.8 meters. Example 2. An object of length 200 cm is photographed when it is 100 cm from the pinhole. If the distance from the pinhole to the screen is 10 cm, calculate the length of the image. Solution. Using similar triangle, we have that x over 200 cm is equal to 10 cm over 100 cm. Therefore, x, making x the subject of the formula, we have 200 times 10 over 100, which will give us 20 cm. Therefore, image length is equal to s, which is equal to 20 cm. Figure 3.5 show an object of height 200 cm and it is placed 100 cm from the pinhole.